So in this session, let's move on to the relativistic quantum mechanics. So we know the basic equation or the equation of motion in quantum mechanics is the Schrodinger's equation. But one trouble is there as far as the Schrodinger equation which we have used so far is concerned, which is it's not Lorentz invariant. We know that when the velocity is so high, which is comparable to the velocity of light, that means when v approaches the velocity of light, c, in those cases, we need frames which are Lorentz invariant. So hope you remember what we mean by Lorentz invariance and all. So the Schrodinger equation which we have used so far is not Schrodinger invariant, Lorentz invariant. So Schrodinger himself tried many, and Dirac, they all tried to postulate new equations or new new forms of the Schrodinger equations which can be Lorentz invariant. Okay, so later scientists like Klein, Gordon and Fogg, they formulated a new equation which is usually known as the Klein-Gordon equation, which is Lorentz invariant and which can be replaced as the old Schrodinger equation in the relativistic quantum mechanics. Okay, so we know that the energy in relativity is usually expressed as p square c square plus m square c raised to 4, where m is the rest mass. Okay, so the energy, the relativistic energy is usually expressed as p square c square. The square of the energy is p square c square plus m square c raised to 4. Okay, so now let us replace the E and vector P by the corresponding operators. So what are the operators? We know that the E operator is simply what was that? I h cross dou by dou t, am I right? And E operator is this, and P operator is simply minus I h cross del, am I right? Yeah. So what would be the square of this? E square. So that is simply minus h cross square dou square by dou t square. When you consider the operator, then p square, what is p square square? Minus h cross square del square plus m square c raised to 4. Clear? So the generally these are operators, so it should act on the wave function psi r of t. Okay, so when these operators when it acts on psi r of t, then I can write minus h cross square dou square psi by dou t square is equal to minus h cross square some piece c square is there, no? Okay, which I missed. H cross square c square del square psi of rt plus m square c raised to 4 psi. Alright, good. Okay, so this is okay, I think. Yeah. Now what I'm going to do is I'm just dividing throughout by h square c square. Okay, so what you will be getting, that is 1 by c square dou square psi by dou t square is equal to minus del square psi plus c square. So m square c square by h cross square psi. Good. Now I take this to the del square to the left hand side. That means del square minus 1 by c square dou square by dou t square. Okay. Operates on psi gives you m square c square by h cross square psi. Now we call this is an entire operator. Okay, now you see this del square part is spatial, am I right? Dou square by dou x square plus dou square by dou y square plus dou square by, so this is something connected to the spatial part, and this is connected to the what do you call, the time part. Now in relativity, the space and time are considered to be together. So in that sense, this operator, this whatever I have written in the bracket is playing a crucial role in relativity, and it is a single operator. This can be considered as a single operator, and usually it is represented by a square. So psi, I mean this operator, the entire operator is represented by a square, and it's called D'Alembert operator. D'Alembert, you know, D'Alembert operator. So D'Alembert psi is equal to m square c square by h cross square psi. Good. Where D'Alembert square is equal to del square minus 1 by c square dou square by dou t square. Okay, so this is called the Klein-Gordon equation, or it's also called the Schrodinger's relativistic equation. This is called the Schrodinger's relativistic equation, or it's again called Klein. Actually, Fock is also there who discovered this, introduced this equation, but it's usually called what you call Klein-Gordon equation. Good. So that's the first part of our lecture, and it's called the Klein-Gordon equation. I think things are very simple, clear. So let's move on. Okay. Now the trouble begins as far as the Klein-Gordon equation. So this is a very simple equation. So you can see it from the, the derivation itself was very simple. Now what happens? Suppose the wave function psi, which I consider here, our usual wave function is psi, which is a function of r and t, which I usually represent. Okay, I think it's normalized. Don't worry about the normalization constant and all. So just consider this is of the form e raised to I k dot r minus omega t. Okay, so these are the plane waves. Okay, so the plane wave solution, let's consider about it. Now usually the wave function will be of this form. Okay, now what I am going to do is, in our Klein-Gordon equation, that is del square minus 1 by c square, this is very easy to remember. Del square minus 1 by c square dou square by dou t square psi is equal to very symmetric m square c square by h cross square psi. Okay, so instead of this psi, let's assume that the plane wave solution I'll be using. Okay, so here one problem is there. Oh, no problem. Anyway, that's correct. So what I can do is del square c minus 1 by c square dou square psi by, oh, not c, psi, dou square psi by dou t square is equal to m square c square by h cross square psi. Am I right? So first of all, let's find out what is del square psi as far as the plane wave equation is plane wave solution is concerned. So del square psi, see, we know that psi of rt we consider it to be e raised to I k dot r minus omega t. ഞാൻ ചെറിയ ഇതിൻ്റെ ഒരു ഫോം മനസ്സിലാകാൻ വേണ്ടി മാത്രം ഐ എം നോട്ട് കംപ്ലീറ്റ്ലി ടേക്കിംഗ് ദ എക്സാക്ട് സ്റ്റെപ്സ് ബട്ട് ജസ്റ്റ് ടു ലെറ്റ് യു നോ വാട്ട് ഹാപ്പൻസ്. ഓക്കെ, so del square, you know that the del square here it is in the r form, so we have to use the spherical polar coordinates. And what is spherical polar coordinate in del square in spherical polar coordinates is simply, what is that, 1 by r square dou by dou r. All right, r square dou by dou r, like this is very simple, e raised to I k dot r minus omega t. Good. So let's do that. First of all, okay, see, let's assume that the k and r are in the same direction, so that k dot r is equal to kr. So what happens? That becomes e raised to I k dot r minus omega t into ik, all right, ik r square dou by dou r. Again that becomes what, 2r, okay, ik is there, 2r e raised to I k dot r minus omega t plus r square e raised to I k dot r minus omega t, again ik. Good. So divided by 1 by r square, so that is ik into 2 by r e raised to I k dot r minus omega t plus ik into ik, so that becomes minus k square, r square and r square get cancelled, minus k square e raised to I k dot r minus omega t. So this is what for the, so this is the del square psi. Now dou square psi by dou t square I have to find out. So dou psi by dou t, what is that? Dou by dou t of e raised to I k dot r minus omega t. So that is minus I omega e raised to I k dot r minus omega t. Good. Again I am taking the dou by dou t of this, that is dou square psi by dou t square. So what would that becomes? Minus minus plus minus, so minus omega square e raised to I k dot r minus omega t. So that is the so now you have 1 by c square, so 1 by c square dou square psi by dou t square is this. Good. So I'm writing it together. What I'm going to get is 2I k by r minus k square, okay, e raised to I k dot r minus omega t minus, oh sorry, minus what, minus, sorry, omega square by c square e raised to I k dot r minus omega t is equal to m square c square by h cross square e raised to I k dot r minus omega t. So everywhere you have this, the exponential terms can be cancelled. Now you get, so you have this, okay, let's write 2i k by r minus k square minus omega square by c square is equal to m square c square by h cross square. Now you see you have a imaginary part and you have some real part. Now I am equating only the real part, so I will be getting minus k square minus so minus omega square by c square is equal to m square c square by h cross square. Good. All right. Oh, I made a mistake because see, this is it. This is already you have a minus here, minus of minus, so that this must be plus, this must be plus. Okay, so that was my mistake. Okay, sorry. So omega square by c square is equal to m square c square by h cross square plus k square. Now I am multiplying throughout by h cross square c square. So what you are getting is h cross square omega square is equal to m square c raised to 4 plus what do you get, plus h cross square k square c square. Good, that's correct. Now you see this is the beautiful thing of h cross k, which we got it as p in the last time. Okay, now p square c square, m square c raised to 4. So this is what? This is simply p square c square plus m square c raised to 4. So this is e square. And of course we know that h cross omega is e. So that is it. Okay, leave it. So now I got h cross omega is equal to, oh, that's a problem. That is the trouble. That is where the trouble, all kind of troubles begin. Okay, so now if you check, h cross omega is simply plus or minus of this. This is square ആണ് അതിൻ്റെ റൂട്ട് എടുക്കുക എന്ന് പറഞ്ഞാൽ you have a plus or minus sign. So plus or minus what do you call h cross square k square c square plus m square c raised to 4 all half. So now there is a trouble. What is the trouble? The energy can be positive or negative. So this means that the energy eigenvalue can have both positive and negative values. So this is a trouble because we know that the energy cannot be negative. So this is where the Klein-Gordon equation landed in trouble. Okay, so usually that Klein and Gordon, they couldn't give a good explanation, a consistent explanation for this negative energy value, so they landed in trouble later on. So we have to solve it. Now the Dirac came with a very consistent solution for this, so that we will call as Dirac's equation. So let's consider the Dirac's equation for a free part. Okay, so ഇത് കണ്ടിന്യൂസ് ആണ്, നിങ്ങൾക്ക് മനസ്സിലാവുന്നുണ്ടല്ലോ. അപ്പോൾ ഒരു ആദ്യം റിലേറ്റിവിസ്റ്റിക് എന്തുകൊണ്ട് വന്നു എന്നുള്ളത് കണ്ടുപിടിച്ചു. ഷ്രോഡിംഗർ ഇക്വേഷൻ നമ്മൾ ലോറൻസ് ഇൻവേരിയൻ്റ് ഉണ്ടാക്കാൻ വേണ്ടി ക്ലെയിൻ ഗോർഡൻ ഇക്വേഷൻ കൊണ്ടുവന്നു. പക്ഷേ ക്ലെയിൻ ഗോർഡൻ ഇക്വേഷൻ വെച്ച് നമ്മൾ നോക്കുന്ന സമയത്ത് ഒരു പ്ലെയിൻ വേവ് സൊല്യൂഷൻ നോക്കുമ്പോൾ energy can have both negative and positive values. The energy cannot be usually negative. So that landed in trouble. So to explain that, Dirac gave a new idea. So we know from the Klein-Gordon equation that the energy is plus or minus, usually what I have written, p square c square plus m square c raised to 4 all raised to half. Now let us replace the old E and P with the corresponding operators and apply those on the wave function psi r of t. So in that case, E is simply I h cross dou psi by dou t is equal to plus or minus p square. P square is simply what you have minus h cross square del square. So you have a c square also. So minus h cross square c square del square plus m square c raised to 4 all raised to half, which acts on psi. Okay. Now, what was the trouble with Dirac? I mean, this equation. So now E p square c square plus m square c raised to 4 എന്ന് പറയുന്നതിൻ്റെ റൂട്ട് വിച്ച് വാസ് നോട്ട് ഡിഫൈൻഡ്. വി ഡോണ്ട് നോ വാട്ട് എക്സാക്ട്ലി ഇസ്. ഐ മീൻ അതിൻ്റെ റൂട്ടാണ് എനർജി എന്ന് പറയുന്നത്, ബട്ട് ദാറ്റ് ഈസ് പോസിറ്റീവ്. സോ വി ഹാവ് നോട്ട് ഡിഫൈൻഡ് ഇറ്റ്. വി ഡോണ്ട് നോ എക്സാക്ട്ലി വാട്ട് ഇറ്റ് ഈസ്. സോ വെരി ബോൾഡ്ലി, very courageously, Dirac wrote c square p square, okay, p square or whatever, p square c square plus m square c raised to 4 is equal to c into alpha x px plus alpha y py plus alpha z pz. Okay, let us write together. Alpha z pz plus beta mc, okay, all square. അപ്പോൾ ഇതിൻ്റെ റൂട്ട് എന്തായിരിക്കും? ഈ സ്ക്വയർ ബ്രാക്കറ്റിലുള്ള സാധനം മാത്രമായിരിക്കും. ഓക്കെ, so this is what he has devised, and we don't know what is alpha, beta and all. Okay, we don't know that, but we will find out that. That was the idea behind, that was the idea formulated by Dirac. We don't know what exactly is this, but let us assume that c square p square plus m square c raised to 4 is the square of something. Okay, so ആ സ്ക്വയർ അതെന്താണെന്ന് കണ്ടുപിടിച്ച് കഴിഞ്ഞാൽ നമുക്ക് അതിൻ്റെ പ്രശ്നം പരിഹരിക്കാമല്ലോ. So now let's consider whatever I have in the bracket inside this. അതിൻ്റെ സ്ക്വയർ ആണല്ലോ. സോ ദിസ് ഈസ് സിംപ്ലി സി സ്ക്വയർ ഇൻറ്റു, ഓക്കെ, ഐ എം ജസ്റ്റ് കൺസിഡറിങ് ദി ആർ എച്ച് എസ്. ഓക്കെ, സോ ദാറ്റ് ഇസ് സി സ്ക്വയർ ഇൻറ്റു ആൽഫ എക്സ് പി എക്സ് പ്ലസ് ആൽഫ വൈ പി വൈ പ്ലസ് ആൽഫ സെഡ് പി സെഡ് പ്ലസ് ബീറ്റ ഇ എം സി all square. Now what I am going to do is I am just squaring it. Okay, don't worry. So c square into alpha x px plus alpha y py plus alpha z pz plus beta mc all square. So this I am going to write as alpha dot p. Korpalalo. This is alpha dot p. Alpha is a vector and p is also a vector. So alpha dot p. So simply that is c square into alpha dot p whole square plus beta square m square c square plus 2 alpha dot p beta mc. Good. Now I have to square this. This is alpha dot p. This is alpha dot p. So let's square it. So c square into alpha alpha dot alpha x px plus alpha y py plus alpha z pz. അതിൻ്റെ സ്ക്വയർ എന്ന് പറയുന്നത് എന്താണ്? എ പ്ലസ് ബി പ്ലസ് സി ഹോൾ സ്ക്വയർ. സോ ദാറ്റ് ഇസ് സിംപ്ലി എ സ്ക്വയർ പ്ലസ് ബി സ്ക്വയർ പ്ലസ് സി സ്ക്വയർ പ്ലസ് 2ab പ്ലസ് 2bc പ്ലസ് 2ca. സോ 2ab എന്നുള്ളതിനെ ഞാൻ ഇവിടെ ക്വാണ്ടം മെക്കാനിക്കൽ ആയതുകൊണ്ട് എ ബി പ്ലസ് ബി എ എന്ന് എഴുതുകയാണ്. The order also is very important. Okay, don't worry about that. Okay, so what I am going to get now is alpha x px whole square plus alpha y py whole square plus alpha z pz whole square plus alpha x px. Okay, alpha x px alpha y py. Okay, let us write it for the sake of simplicity. I mean this what I am okay വേണ്ട നിങ്ങൾ എഴുതി കഴിഞ്ഞാൽ അത് തെറ്റിദ്ധരിക്കും. Okay, don't worry. alpha x px plus തിരിച്ചെഴുതാം alpha y py alpha x px plus what is the next term? Alpha y py alpha z pz plus alpha z pz alpha y py plus alpha z pz alpha x px plus alpha x px alpha z pz. Okay, plus okay, so ഇതിൻ്റെ സ്ക്വയർ കിട്ടി. Now what? beta square m square c square plus 2 into alpha x px plus alpha y py plus alpha z pz into beta mc. Beta mc. Okay. So this is equal to what? On the right hand side, on the left hand side, you have p square c square plus m square c raised to 4. So both the side has to be same. So now you consider. So this is px square plus py square plus pz square. So ഇത് multiplied by c square ആണെന്ത്? p square c square എന്ന് പറയുന്നത്. So what does that imply? So that simply implies that എന്താ നമുക്ക് എഴുതാൻ പറ്റുക? So simply from these equations you can simply say നോക്കൂ ഇത് px square plus py square plus pz square into c square ആണെന്ത്? p square എന്ന് പറയുന്നത് അല്ലേ? So p square is simply, we know that p square is simply px square plus py square plus pz square. So ഇത് 1 ആവണമെങ്കിൽ എന്ന് പറഞ്ഞാൽ ഇതിൻ്റെ അർത്ഥം എന്താണ്? So simply that means alpha x square is equal to alpha y square is equal to alpha z square is equal to 1. That is one condition, very simple, important condition. Now you consider what about beta? Beta square m square c square into c square, that is m square c raised to 4 is equal to m square c raised to 4. That also means beta square is equal to 1. That's the other condition. Now the last one, all other things, that is has to be 0. That is alpha x alpha y plus alpha y alpha x. നമ്മൾ തിരിച്ചു മറിച്ചു എഴുതിയ സാധനങ്ങൾ alpha x alpha here alpha x alpha y plus alpha y alpha x has to be 0, and alpha y alpha z plus alpha z alpha y has to be 0. Alpha z alpha x plus alpha x alpha z has to be 0. That means these are all what you call anti-commuting things. Anti-commuting. So these are anti-commuting. Minus ആയിരുന്നെങ്കിൽ commuting. So these are anti-commuting things. and their squares are 1. Okay, squares are unity and these are anti-commuting things. So what kind of a thing, അങ്ങനെയുള്ള ഒരു സാധനം നിങ്ങൾ ഇതുവരെ പരിചയപ്പെട്ടിട്ടുണ്ട്? സംതിങ് അതിൻ്റെ സ്ക്വയറുകളൊക്കെ എന്താണ്, ഒന്നാണ്, പക്ഷേ അവ രണ്ടെണ്ണം അടുത്തടുത്തുള്ള രണ്ടെണ്ണം എടുക്കുകയാണെങ്കിൽ, ഐ മീൻ സൈക്ലിക് ഓർഡറിൽ രണ്ടെണ്ണം എടുക്കുകയാണെങ്കിൽ ദേ ആർ ആൻറ്റി കമ്പ്യൂട്ടിങ്. സോ ദീസ് ആർ സിംപ്ലി അങ്ങനെ ഒരു സംഭവത്തിൽ നമുക്ക് പരിചയമുണ്ട്. ആൻഡ് ദാറ്റ് ഈസ് നത്തിങ് ബട്ട് പോളി സ്പിൻ മാട്രിക്സ്. നമ്മൾ പഠിച്ചിട്ടുള്ളതല്ലേ പോളീസ് spin matrices. Okay, very good. So these are Pauli's spin matrices. So somehow this is എന്താണെന്നുള്ളത് നമുക്ക് വരാം അതിലേക്ക്. So somehow these are connected to Pauli's spin matrices. So Pauli's spin matricesൻ്റെ ടേംസിൽ നിങ്ങൾക്ക് now you can express this energy E is equal to plus or minus C alpha dot P plus beta MC എന്ന് പറയുന്ന സാധനത്തിനെ നിങ്ങൾക്ക് എക്സ്പ്രസ് ചെയ്യാൻ പറ്റണം അല്ലേ? അങ്ങനെയല്ല നമ്മൾ എഴുതിയിരുന്നത്. സോ ദാറ്റ്സ് വാട്ട് വി സ്റ്റാർട്ടഡ് ഇറ്റ്. ഓക്കെ, സോ യു ഷുഡ് എക്സ്പ്രസ് ഇറ്റ്. Now we got it. Now the energy E is equal to this. Good. So now I can write I H cross. Let's replace it by the operators. Dou psi by dou t is equal to okay, so this is simply C into okay, let's write C into alpha dot P plus beta MC square. So now I can write P I can replace with the operators. So okay, so I H cross dou psi by dou t, right hand side, I mean left hand side, is equal to P. P യുടെ ഓപ്പറേറ്റർ എന്തായിരുന്നു? മൈനസ് ഐ എച്ച് ക്രോസ്. സോ മൈനസ് ഐ എച്ച് ക്രോസ് some C is there. So let's put that alpha x dou by dou x plus alpha y dou by dou y plus alpha z dou by dou z. അല്ലേ, ഇതൊക്കെ ഓപ്പറേറ്റേഴ്സ് അല്ലേ, ഓർമ്മയില്ലേ? സോ വാട്ട് ഇസ് പി എക്സ് ഇസ് ഈക്വൽ ടു മൈനസ് ഐ എച്ച് ക്രോസ് ഡോ ബൈ ഡോ എക്സ് ആണല്ലോ, ഓർമ്മയുണ്ടല്ലോ? അതാണ് ഞാൻ ഇവിടെ എഴുതിയിരിക്കുന്നത്. ഓക്കെ, ഓപ്പറേറ്റ്സ് ഓൺ psi plus beta mc square psi. Wow, this is a beautiful equation, and this equation is known as Dirac's relativistic equation for a free particle. This equation is Dirac's relativistic equation for a free particle. We haven't considered the potential here, so that's why I am calling it as a free particle. So this is the Dirac's relativistic equation for a free particle. So it's a very simple equation, very elegant equation. So now still we haven't devised what is alpha x, alpha y and alpha z and beta. Now we need to express this alpha x, alpha y, alpha z and beta in terms of the Pauli spin matrix that we will do in the next class. This is a fundamental thing. Okay, so in the next class we will derive what is these Dirac matrices or alpha x, alpha y, alpha z and beta. What are they? But anyway, for the sake of simplicity, let's assume that these are matrices. We will come to that in the next class. So this is the form of Dirac's relativistic equation. Thank you.